Good morning, everyone. So today, in the second part of this lecture, we are going to discuss about the numerical problems relating to the charge. So in the previous two lectures, we have seen there are two kind of charges, positive charge and negative charge. Basically, the atom is whole as neutral. Positive charge is formed by losing of electrons and negative charge is formed by gain of electrons. So the deficiency of electron is positive charge and gain of excess of electron is negative charge. So then we have discussed the properties of the charge, that the charge is being quantized. Quantized means charge can be written as integral multiple of n into e. So n into e, where n is an integral number. Integral number, why? Because when the electrons are being transferred from one to another, it is only a fixed number of electrons which are being transferred, not a half of electron. So due to that, only fixed numbers are being taken. Second, the charge is always a scalar quantity. Why the charge is a scalar quantity? Because it has the magnitude as well as, but no direction is there. And the value positive or negative, it can be simply added rest like an ordinary number of 2 plus 3, 5 plus 6, 5 minus 6, like that way. So same numbers can be added like this way. So conservation of charge, the charge remains conserved. That is, before and after the reaction, the charge is always same. Let us say this is a 0 comma ray. Before reaction the charge is 0, after reaction 1 plus 1 minus 1, and you add them, it will be 0. So before and after reaction the charge will become 0. So these are the properties we have discussed. Now we are going to discuss the numericals based on this particular charge. One of the problem we have discussed in the previous topic, in the previous articles, in the videos. Now next problem we are going to discuss, let us say second problem is an object has excess charge of minus 1.92 10 raised to minus 7 coulomb. So this is the excess charge which is being there. How many electrons does it have? Then how many electrons does it have? Now since we are given total charge Q is equal to minus 1.92 10 raised to minus 7 coulomb. So what does it mean? It means that the total charge which being, it is a negative charge. Negative charge means excess of electrons are being given to it, added into it. Now how? Because negative means excess, positive means deficiency. We have seen it previously. So negative means excess of electrons are there. So total charge is being given and we have to find number of electrons. So since we know the charge on electron is 1.6 into 10 raised to minus 19 coulomb, that is the basic charge. So we apply the formula, Q is equal to N into E. So minus 1.92 10 raised to minus 7 is equal to N into minus 1.6 10 raised to minus 19. So minus sign get cancelled. So n will be equal to 1.92 divided by 1.6 10 raised to minus 9 divided by 10 raised to minus 19. So that will be approximately equal to 192 upon 100 into 10 upon 16 into 10 raised to power 10. So that value comes out to be some fixed number, so that you can able to get it out. So that is how one particular kind of charges have been solved it out. So next will be a textbook question. So where we have to find out how many positive and negative charges are there in a cup of water. So that is a very funny question. So we take a cup of water, let us say cup, it is like this way. So this is a plate. So you are going to take, now this cup is filled with water, and how many number of positive and negative charges are there. We know that water formula is this one, and its mass will be, you can able to find 2 into 1 plus 16, that is 18 gram. Now in cup of water, how much water can be filled is, volume is 250 ml. and if you take the density and then you can density is equal to mass upon volume, so which implies mass is equal to density into volume. So this mass comes out to be approximately 250 gram. Now, how to find the number of atoms in 250 gram? We know that in the chemistry you have learned that in 18 grams contains 6.023 10 raised to power 23 atoms. So 1 gram contains 6.023 10 raised to power 23 divided by 18. And in how many number of in 250 gram? It will be 6.023 10 raised to power 23 divided by 18 into 250. So this will be your number of atoms. So now we have to find out the number of charge. So we know how many positive and negative charges are there. So this is the total amount which is going to be the total number of atoms in this one. So this represent total number of atoms which will be come out to be in water molecule. Now each water molecule contains how many electrons? 10 electrons, and will be equal to, so total number of electrons will be equal to 10 into whatever the this value comes out to be 10 raised to 23 upon 18 into 250. So this will be the total number of electrons. Why 10? Because water has 2O, hydrogen has 2, oxygen has 8. So 8 plus 2 is 10. So 10 electrons are there, 10 positive charge and 10 electrons are there. So equal number of positive and negative charges are there. So we have the amount of charge n into E. So n into E, you can able to find out the value of n is this one, same, and multiply it with 1.6 into 10 raised to minus 19 coulomb. So it comes out to be 1.3 10 raised to power 7 coulomb. So this amount of charge is going to be present so in 1 ml of in 250 ml of water, cup of water. So that is the kind of problem how we can able to solve it out. So that is how this quantization of charge help us to finding out the such kind of problem. So now we are moved to next problem is again a textbook question. If a body gives out 10 raised to 9 electrons per second, means this much electrons are being emitted out, how much time is required to get total charge of 1 coulomb. So now this problem you have to understood it, then we can able to apply it. And if a body gives out 10 raised to 9 electrons per second, means this much is the number of electrons which are being emitted out in 1 second. So now first of all, what we have to find out the total charge present in 1 second. Now total charge, the charge present in 1 second will be equal to n into E. So that is equal to 10 raised to 9 into 1.6 10 raised to minus 19. So that is equal to 1.6 10 raised to minus 10 coulomb. So that is this much charges passed just by the body in 1 second. Now total charge we are being given, total charge is equal to 1 coulomb. So 1 coulomb divided by 1.6 into 10 raised to minus 10, that will be the time required to get that charge. So this much charge is being accumulated or gathered by 1 second, but we have to gather this much amount of charge. So time we have to calculate it out. So that's why 1 coulomb has to be divided by this one. 1 coulomb divided by this one, you will get the amount of time. So that will be 1 upon 1.6 into 10 raised to power 10 seconds. So that can be converted into years, which will be comes out to be approximately 198 years. So that means this much time is required to get a charge of 1 coulomb. Although our body was giving 10 raised to 9 electrons per second, so this much electrons are being emitted. So this much electrons means this much charge per second was being emitted out. So after how much time 1 coulomb charge will be emitted? That is means after 198 years this much charge will be emitted. That is how the problems could be understood. So such kind of problems are very useful in calculating the charge and measuring the number of electrons, and different kind of problems can be get it solved out. So next time we are going to discuss the next topic of force, that is Coulomb's law. Thank you.